Hello everyone, welcome to Glecta. In the last class, we studied about force, the types of forces, and we wondered lots of questions, right? In today's class, we'll learn so much more about it. So I hope you all are ready for it, right? So just recall something that we learned in the last class, which was about the types of forces, and we came across two types of forces. One was the contact force, in which I told you that in contact force, the object in which you have to apply force and the object which is applying force has to come in contact with each other, right? There will be an interaction between each other. So these were the examples of contact forces, as you can see in the picture. In the other one, the non-contact forces, I told you that there were the forces which is applied, like the object which is applying the force and the object which is being applied to the force on, they both are not in interaction with each other. They are not in contact with each other, but still they are able to make an impact. How? By applying force from a distance. It can be attractive, it can be repulsive, but there is the force. And that is what we know about non-contact forces. Now over here you can see what's the kid doing. He is trying to push the stone in the first picture, and in the second one he's trying to pull the box. Fine. So let's concentrate over the first one. In the first photograph, what he's doing, he's trying to push the stone. That's what we studied in the definition of force. That force is what? It's a push or a pull on an object when there is an interaction. Fine. That's what we studied. So what he's trying to do, he's trying to move the stone. And how will he be able to do that? That there is a certain weight in the stone. And in that weight, the person has to apply force much enough that the weight of the force is being overcome. To overcome that weight, the kid has to apply more force to it, right? And if he is not able to apply much more force than it, the stone won't be able to move. To make it move, you have to cross the weight level. So if you ever wondered, like, what is weight? If you measured your weight, what is weight? Weight is nothing, but it's the force the gravity is applying on an object. You just calculate how much force the gravity is applying on that object to make it heavy. That is why when we pull an object, it's heavy. That is the amount of force the gravity applies, right? Now, if you're able to pull the box towards you, so what you have to do, again, you have to apply force much enough that it makes it move. And it should cross the level of its weight, right? Now, over here, in both of the diagrams, you know what is push and what is pull. Over here, what's happening over here? You know this game, right? Tug of war, or you must have played this game as well. So over here, both the teams have a bow. They just pull it in the opposite directions with certain force. Whosoever applies more force, they win the game, because they try to make the team players go out of their line, out of their area. So over here also what they are doing, they are applying force on each other. They're trying to pull the other team towards them. So what they are doing, they are pulling it, right? They are pulling it. And if they just leave it right there, will the row be able to move by itself? No. So what it says, that you have to apply force on your own so that the row is able to make the other team move towards you. Right? So you have to apply that much force. Over here, what is happening? You may guess on your own. The force direction we are going to study. There are two people. They are kicking the ball towards each other. Right? Why is the ball going towards the other person straight away? Why is it's not going anywhere else? Because you have sticked it with the direction. The ball will move only towards that person because you are making it move in that direction. The force is applied towards there, right? So that is why there's an interaction between the two people with the help of the ball, because they are moving it in that direction. What you get from this? what is the short summary of this picture? You may wonder, right? Over here, what you got to know that force is also responsible in direction. So it's related with direction. If you want to move the ball in the other direction, you have to apply force towards that direction. That means the direction is related with force, right? Force can change the direction. All right. From here, we're going to come across this Newton's first law. We know what Newton did. He gave the gravity. He gave us so many laws, and now since we are working on force, I will make you know what's Newton's first law. In the first law, what's happening? When an object is at rest, if you have your pencil box, it's right on the table, it's at rest. It will remain at rest. Fine? So when an object is at rest, it will remain at rest. And when an object is in motion, it will continue to move in uniform motion unless and until an external force is applied on it. Alright? So what do you say? That if your pencil box is on the table, it won't be able to move on its own. You have to apply external force. Since you will apply the force to lift that box from one place to another, what you did, you applied the force. Right? So that is why I said, if it's at rest, it will remain at rest. And if a car, suppose a car is in continuous motion, it will remain in continuous motion unless and until an external force is applied on it. Right? If you want to stop the car, what you'll do, you'll apply brakes and then it will stop. So in both of the ways, if you didn't do anything, it will remain at rest. If you did apply some force, it will stop and not move in that continuous motion. So in both of the cases, what we did, we applied some force. Over here in the diagram, what is you must be felt this way. You have felt this way when you're driving a car, and when you applied some brake, you will fall forward, and when you start the car, then you will a little bit fall backwards. Why is that so? Or if you're traveling in a train, when the train will start, you will move a little bit backwards, or in a bus, you will fall a little back. And when it will apply a brake, you will fall forward. Why is that so? Over here also, Newton's first law is the reason. How? Like when you and the bus, at the beginning, they both were at rest, right? Now, the engine started, the bus started moving. But you, sitting inside the bus, was still at rest. And that is why, for you to come in motion with the bus, it requires some duration of time. And in that time, what happens? You move a little bit backwards. In actual, you didn't move a little backward, the bus moved a little forward. And that is why you feel you are left a little backwards. Now you know why such happens? Next, when the bus applies the brakes, you move a little forward. Why move a little forward? Because with the bus, you were there in a continuous motion. Now when you were there in continuous motion, the brake was applied, the bus was stopped. Now the bus was stopped, but you need some time to stop. So you were in continuous motion, and then after some time, when the brake was applied, then you also stopped. Right? So in both of the cases, when the bus started and when bus stopped, in both situations, what happened? You take few seconds of time to match with the bus, to match with the state of the bus, right? So that is why it happens. When the car starts, you fall a little back, or when the bus starts, you fall a little back, and when it stops, you fall a little forward. Now you know how is this first law applicable? Think of many more examples where you can feel the first law. Okay, I'm going to show you over here. Now, before I explain this one, I want you to know that first law of Newton is also called law of inertia. Alright, now this law of what I mean by inertia is the property of matter. What is the matter? Everything in this world is called matter, right? So it's a property of matter by which it continues in its existing state. in its existing state. That means if the state was at rest, the object will remain at rest. And if it was in motion, it will remain in motion. Till when? An external force is applied. Fine. Now over here, that is what I mean with inertia. Now you know, right? That is why inertia, law of inertia, or Newton's first law, you can say either things. Fine. Now over here, there was a glass, and above the glass, there was a small piece of thick paper. Over that, there was a coin. Alright. Now what happened? The person flicked the paper with a good amount of force, but the coin fell in the glass instead of moving with the paper. Why that happened? It happened because the person, when he flicked the paper, he applied enough force that the paper became in a good amount of motion, and with the coin, what happened? It remained at rest, and when the paper just went away, it fell down. Because it requires, like just like I told in the previous example, in the bus, what happened? When the bus stopped, you need a few seconds of time to match with the state of bus. Same as with this coin. It needs some time to match with the state of the paper. If the paper was at rest, the coin was also at rest with the paper. But when the person flicked the paper, the coin fell in the glass, because it requires some time, and in that time the person applied force enough to flick the paper that the coin didn't have enough time to match with that state. Alright, now you know what I mean by law of inertia. Okay, now what's the next topic? We are going to know when force act on object, they have following effects. You can now imagine these effects. You know these effects do happen. We have come across these examples, right? So in the first point where it says the object can speed up or slow down. Yes, for example, you're driving a car, you can speed up or you can slow it down. So that means when force acts on an object, it can have this effect, right? Now in the second point what it says, the object can change direction. The kid, he was kicking the ball, he was kicking it in a certain direction. This is what it says. It says that the object can change the direction. Now, the shape of the object can change. When we talked about the spring, you can pull it away from both sides of its ends, and you can push it inside with both of your hands from its corners. Now, what's happening in this case? The shape of the object can change. You can change it. So now you know that these three things do happen when the force is being applied. Now, this term, resultant force, we are going to get ourselves familiar with. Okay. Now you can make your own imagination when I say resultant force. By resultant, what I mean? The force which is related with the result. Okay, we know that word result. So over here, to make it more clear, let me define it. When two forces act in opposite direction on an object, resultant force is the difference of those two forces. Okay, so there is an object, two forces, there has to be two forces, at least two forces, which is to be applied on an object. Okay, so at least two forces are supposed to be applied on an object in the opposite direction. Okay, in the opposite direction, two forces are applied on an object, and the resultant force. What is the resultant force? What will be the result of these forces? The resultant force will be the difference of these two applied force. Okay, if you applied, suppose 10 Newton from one side, and you applied 12 Newton from the other side, so the difference of these force will be 2 Newton. So this 2 Newton will be the resultant force. We will get familiar with this in much more way. We will learn it again. Okay. What other thing says? The direction of resultant force is the direction of larger force. Right. Let's make it clear with this one. Okay. Over here there's a box. This box felt a force from one side of 45 Newton and from the other side of 25 Newton. And in both situations, what's happening? The opposite force is being applied. And there's an object and an opposite force is being applied on that particular box. And both of the forces are different. They are not same forces. Keep that in mind. They are not same forces. Okay? Now, one force is of 45 Newton, other is of 25 Newton. So what will be the resultant? It will be the difference of the two. The difference of the two will be 20 Newton. Alright? And in which direction? The direction in which there was larger force applied. The larger force was applied in 45 Newton. The larger force was 45 Newton towards the right direction. So it will move towards the right direction. Alright? Now you know what's the resultant force? It's very simple, okay? Resultant force, by the name you know, is related with result. And what do I mean when I say result? That means it's a difference of the two forces, okay? Difference of the two opposite forces. Keep that in mind. Alright? Now the another term, balanced force. So the balanced force, what it says, that the object will remain in balance, in the state of balance. Fine. So when two forces act on an object, alright, there will be at least two forces which will be applied on an object in opposite direction. Okay, there is an opposite direction. From an opposite direction, forces are being applied on an object. The resultant force is 0. Oh, now you can relate with in the first slide which I said, we'll experience Newton's law in the two situations. What I said, the first was when the resultant force will not be 0 and when it will be 0. Here you can relate it with. Now you know what is over here. When two forces act on an object, there are two forces from an opposite direction and it will be applying on an object. The resultant force is 0. Alright, the resultant force will be 0. So how the resultant force will be 0? Definitely, when I said resultant means the difference of the two, and the difference of the two, when it will be 0? When there will be two same forces, right? So 25 Newton from one side, as you can see over here, and 25 Newton from the other side. And in both, what happened? They were both same, so they cancel each other, so the box didn't move. So if I ask you, in which direction will this box move? You will say, the box won't move, right? Over here, now you may wonder, but when we apply force, the box has to move in a certain direction, but that is when balanced force I mean with, right? So in balanced force, you apply two same force and the box, that is why will remain at that same position where it was. Alright? Okay, so now we're here. If I ask you what the resultant force will be, you can tell me, right? So there is one person who is applying force in one direction and there is another person who is applying the force in the opposite direction. So there are two forces again. The two forces are being applied in the opposite direction over what? On an object. And what will happen? Since they both are the same forces, they will cancel each other out and the result will be 0, right? So this is what? Balanced force. Over here, the box will remain at its position. It will remain balanced. Okay. The next term is unbalanced force. When I say unbalanced force, you can relate it with something which is not at its state of balance. Okay. So when two forces act on an object in an opposite direction and the resultant force is not 0. That means there is an object, you applied two forces from an opposite direction over it and the resultant force, that means the difference of those two forces is not 0. That means the box will move in one direction or the other direction. Alright? The other thing says the direction of the resultant force is in the direction of larger force. Obviously, if you apply 12 Newton force from one direction and you apply 10 Newton force from the other direction, where will the box move? It will move in the direction where larger force was applied from. It was applied from 12 Newton. So it will move towards right. And when it will move towards right, with how much force? With the difference of these two. That means with 2 Newton, right? Here is the example for unbalanced force. There is a box and one force is applied from 35 Newton. Other force is applied which is of 12 Newton. Now you can find out if it's balanced or unbalanced. It's obviously unbalanced. Why? Because the box will not remain at its state. It will change its direction. And where it will move? Where the larger force is applied from. And it is applied from 35 Newton. And how much force? You can calculate by the difference of 2, which is 35 Newton subtracted 12 Newton, which is 23 Newton. And in which direction? Right direction. Alright, now you can see the difference in the balanced and unbalanced force. The first thing is, in balanced force, 2 same forces are there. In unbalanced, 2 opposite forces are there. In balance, the box will not move, because both of the forces will cancel each other. But an unbalanced force, it will move in one direction, because there are 2 opposite forces. They are not same forces, right? So the larger force will make it move. Okay. Over here, equal and opposite forces. Now this one is also Newton's third law. Equal and opposite forces. It says that when an object interact with each other. Okay, so the 2 objects need to be interacting with each other. Then that is how they will make impact on each other. They are able to apply some force. So when an object interact with each other, they exert equal and opposite force. Fine. They do apply equal and opposite force. So over here you can see there's a boxer, right, who punches the bag with 100 Newton. She applies some force on the bag, and how much force? 100 Newton. And experiences equal and opposite force from the bag, right? So that is why they do wear gloves, okay? So she applied 100 Newton force on the bag, and she also experiences that amount of force from that bag, which means the amount of force you apply to an object, you also experience that same amount of force backwards, right? So if I say she punched that with the 100 Newton force, so how much force she will experience? Obviously 100 Newton, but in an opposite direction, that is why we always say she experienced minus 100 Newton. Why minus? Because she applied in one direction and the force she experienced was in opposite direction. And by negative sign, the negative sign represents the opposite direction. Okay, so this is what equal and opposite force is all about. Now speed. Speed is a measure of how fast something is traveling. Alright, so if you want to know how fast something is traveling, you should know how much speed it has. And it is the distance traveled per unit time. So the amount of distance an object or someone traveled, you just divide it with how much time it took. Then you can find what the speed is. For example, over here it's written 10 km per hour. What it means is that in an hour, in 1 hour, 10 kilometers of distance was traveled. Alright, so speed is what? It is the measure of how fast something is traveling or how slow something is traveling. So you should know how much distance it has and how much time it has taken. You can do it otherwise as well. If you know the speed and you know the time, you can find the distance, right? And if you know the speed and you know the distance, you can also find how much time it took. So it works all the ways. This is the distance time graph. Okay, for the time graph, distance time graph, there's an origin you can see. Alright, there's an origin and an x-axis and there's a y-axis. On x-axis there is time, which is represented in seconds. In the y-axis there is distance, which is represented in meters, right? So over here you can see when there was 10 meters of distance, how much time it took? It took 5 seconds. The object took 5 seconds to travel 10 meters of distance. That is how the graph is all representing, right? So if I ask you, an object took 15 seconds of its time to travel some distance. So from the graph, tell me how much distance is being traveled. So you can now answer it. Like in 15 seconds, you can see the distance was how much? 30 meters, right? So we notice the slant line. Slant line over here represents the uniform motion, right? That means in the 5 seconds, 10 meters of distance is covered. In 10 seconds, 20 meters of distance is occurred. So this is the equal interval of time is, right? Speed during the course of traveling is constant. So there is a straight line, right? This straight line represented over here, right? This is the time, over here is the time, and up here is the, right here, this is the distance, and this is the origin over here. It's a 5 seconds, you took 5 seconds, and in 5 seconds you travel 10 meters of distance. In 10 seconds you travel 20 meters of distance, and over here in 15 seconds you travel 30 meters of distance. Alright, so now you can understand what is distance time graph. Now answer some questions. A jet plane lands on a runway and stops. State the direction of the resultant force on the plane. Here's a question in front of you. There is a jet plane and on a runway it stops. Now you have to tell the direction of the resultant force on the plane. Now you know what's resultant force? Resultant force is the difference of the two forces which are applied on that object. In this diagram, you can over here see that there is a plane. The two forces, which are these two forces? One is the thrust. Thrust is because of the engine. The force because of the engine. It moves the plane in one direction. And there's some drag force. Alright, drag force is what? Making it balance. And the plane is moving forward. When the thrust force will be greater than the drag force, the plane will move in one direction and forward. And when the drag force will be greater than the thrust, the plane will reduce its speed and will stop at one point, right? So if I ask you, state the direction of the resultant force on the plane when it stopped. So the direction of the resultant force will be the thrust minus the drag force. And in the direction, definitely opposite. Why? Because it stopped. If it stopped, the drag force it was greater than the thrust. So that is how it stopped. So over here, every object persists in its state of rest or a uniform motion in a straight line unless it is compelled to change that state by forces impressed on it. This is what Newton's first law is. And over here, since I asked you, what is the resultant force when the plane stops? So the resultant force will be the force, drag force subtracted with the thrust force. That is why it stopped, because the thrust force will make it move forward, but we don't want to make it move forward. Now here, a hammer hits the nail with a downward force of 50 Newton. What is the direction and size of the force of the nail? Okay, so there was a hammer. You hit the nail with that hammer, and with how much force? With 50 Newton force you hit that. Alright, now you were asked, what is the direction and size of the force of the nail? Okay, obviously since you are applying force in a direction downwards, so where it will go? It will move downward. Now you are asked direction of the size of the force of the nail. How much force? 50 Newton force. Why 50 Newton? Because as much force you apply on an object, the object gives you that much amount of force in back direction. So if a hammer is applying 50 Newton force on the nail will apply the same force in the opposite direction. That is why it's minus 50 Newton. 50 represents the size, the amount of force, and negative sign represents direction. And direction is opposite. Opposite of what? in which direction the hammer applied the force. Okay, so if the hammer applied it downwards, the force experienced by the hammer is upwards, and that is why it's negative. And how much? That's 50 Newton. Why 50 Newton? Because that was the same amount of force the hammer applied on the nail. Alright, so now I hope you are aware of this topic. You are aware of what is resultant force, what is balanced force, what is unbalanced force, the various applications of forces, about the speed, the distance time graph, and obviously the Newton's laws. Alright, Newton's laws when? The 2 points which I told you in the very beginning of this class, that the first one is when a resultant force is not 0 and when the resultant force is 0. So in both the cases, now you know where are these. Alright, so I'll see you in the next class. Hope you enjoy the session, and if you have any questions, do ask. Thank you.